Well, if you've made it this far, you've already practiced an awful lot with exponents, and now it's time to put exponents into something more, order of operations. You did this in fifth grade also. Let's see what you remember. There's a word or some letters that we use when we want to remember order of operations, and I'm pretty sure you learned this in fifth grade, but let's look at it again. Okay. Here we have the anchor chart on order of operations. And if you see right here down the side, we have the word PEMDAS. I'm sure you talked about this in fifth grade, but let's just review. For order of operations, we start with the parentheses, then we move to the exponents, which you've been practicing an awful lot. Then we solve multiplication or division within the same step, whichever comes first, moving left to right. Remember, multiplication and division are done in the same step. And then we have addition and subtraction, and they're done in the same step. So if we look at this problem, here we have the P for parentheses, so we solve what's in the parentheses first. What's in the parentheses is an exponent and a division problem. So we have to do the exponent before we can do the division problem. So 2 to the power of 3 is 2 times itself 3 times, and we solve that and get 8. Now we rewrite the problem. 9 times 8 divided by 4. See, 8 represents the 2 to the power of 3. The next thing we do is solve the rest of what's in the parentheses. 8 divided by 4 is, that's right, 2. So now we can rewrite the problem again, and I'm going to be a real stickler about this. I want to see you rewriting the problem each time you solve another step. That's how I'm going to be able to tell if you're working in the correct order. And I promise you I will give you partial credit on anything I do as long as I can see which step you made your error in. 9 times 2 plus 5. 8 divided by 4 is 2. Next step, multiplication and division, okay? Here we have a multiplication problem. 9 times 2 is 18. We have to do that before the addition problem. I know you normally would going left to right, but even if they were switched, you have to do multiplication before you do addition. And last but not least, the addition problem. Let's look at a problem on the board and see what happens if we don't solve it by using order of operations. So 12 plus 6 times 2 minus 24. Okay. So here we have the problem, 12 plus 6 times 2 minus 24. Order of operations says that we have to do parentheses, well, there are no parentheses, exponents, there are no exponents, and then we have to do multiplication or division before we do addition or subtraction. So in this problem, we have one multiplication problem, so we have to do that first. 6 times 2 is 12. So now I'm going to rewrite the problem. 12 plus 12 minus 24. Okay, 12 plus 12 is, because now we're doing addition and subtraction in the same step, going left to right. So we have 12 plus 12 is 24 minus 24, and the answer to this problem is 0. Now, what if I had just worked this problem out going from left to right and not using order of operations? Let's see what would have happened. Twelve plus 6 is 18. 18 times 2 is 36. Minus 24 would give me 12. Uh-oh, I didn't get the same answer, did I? So if you're not going to use order of operations to solve the problem, then you're not going to get the same answer as the person who wrote the problem, and that's going to throw off calculations. That's why it is accepted that there is an order of operations to solve problems, and you have to use that order of operations in order to have an understanding of how things work mathematically. All right, so now there's a Math Antics video for you to review order of operations, just like what we did here, and it might explain it a little bit better. There's also some problems that you're going to practice,